So my name is Cabrero, and what I'm presenting today is a proof of concept, something that I wrote during a SUSE Hack Week for a specific use case, something very experimental but fully functional that did not get traction. So in this talk, I will explain what the motivation was, show the use case, and hopefully catch some attention to discuss its future. Just a few words about me. I started my open source journey in Sential, integrating Samba 4.0 in Sential server. And here's where I had my first contact with the Samba team, giving my first sambaXP talk in 2013. After that adventure, I joined SUSE in 2017 and became an official team member in 2019. Okay, so straight to the point, what varlink service is. It's a Winbind NSS module replacement for users and groups based on smbd recent features. And what is it for? No surprise here. It's for the same as Winbind NSS module. Then what the motivation was? Well, it's too early to get an answer. Let me defer to the end because I think it will be better understood. I have said that this work is a replacement for Winbind NSS module. So in case anyone is not familiarized with name service switch framework, I will say a few words about it. I will also use this graphic later to illustrate what the replaced parts are. In a computer, we can have different sources of information for different types of information. The different types are called databases in NSS terminology, and we have, for example, the past availability database for users or the group database for groups. For each database, we can have different sources like an LDAP server or just a plain text file. The different sources provide the data to the NSS framework in shared libraries called modules. Trying to summarize what the NSS framework is both an interface for clients to query the database and an interface that the different modules have to implement to provide this information. In the graphic, we can also see the nsswitch.conf file. This file is very important because it states the order and preference of the different modules. Going deeper into the Winbind NSS module, these are the functions implemented in it. Basically, there are functions to query a user by its name or its ID number, same for groups, and functions to enumerate users and groups. The information is always returned to the caller in the past availability and group structs, which are based on the etc past availability and group file fields and limited to it. If there is extra data about a user, like its public SSH key, for example, it has to be retrieved directly by the application using other mechanisms. Okay, after this very basic NSS introduction, let's jump into the smbd features taking over the NSS role for user and group databases. This feature is called the User and Group Record Lookup API, and it's no longer considered experimental today. As NSS, it defines both a way for applications to query user and group records and a way for subsystems or services to provide these records, which are JSON encoded and transported using the varlink IPC protocol. This API is very simple and only has three methods requiring a small subset of the varlink features. In this small slide, there's a lot of information. In just a few words, I mentioned varlink, the smbd record lookup API, and the smbd user and group records. In the next slides, we will go into the details of each one. I will start with varlink, the mechanism used to transport the record. It's an IPC protocol and an interface description format at the same time, where the messages are JSON encoded and the transport is connection oriented. You can think about it as a dbus alternative. The interfaces that a varlink service provides are defined in plain text and have their own syntax, which is intended to be easily read by machines and humans. The name of the interface is in reverse domain format, and the definition contains which method the interface implements, the types, and the errors returned from the method calls. Here we can see the definition of the smbd's user database interface and its three methods. It's very simple. There are no complex types, and there are only 5 possible errors that methods can return. Talking about the protocol, the messages are JSON encoded and terminated with a single null byte. To simplify things, the messages are always responded in the order they arrive, and multiple requests can be queued. It's important to mention that the protocol has a mechanism to deliver multiple answers to a single method call. This is explicitly requested by a client when making the call by setting the more flag in the request, and the server will set the continue flag in its response to let the client know that there are more answers to come. In our case, this is used for enumerating users and groups. Here in the slide, we can see a method call to enumerate the users, and all response will have the continue flag set except the last one. There is also a special interface called org.varlink.service offered by all varlink services. This special interface defines 2 methods to obtain information about the interfaces that the service provides and about the service itself. We will see later an example. Finally, why varlink? Why systemd choose this protocol instead of, let's say, dbus? The first reason is because it can be used during early boot and late shutdown. Second reason is because it's JSON based, so it's a natural choice to transport JSON data. And the third one is because it allows streaming, as it is connection oriented. So this is very useful for enumerating users and groups. Now that we know how to transport the records, it's time to describe how the systemd record lookup API is used. On the service side, every subsystem that needs to define users and groups on the local system needs to 1. Implement the io.systemd.user database interface, and 2. Listen on a Unix socket in the run systemd user db directory. On the client side, every client that wants to obtain a record has to contact all sockets in that directory in parallel and queuing the same query to all of them. And the first positive response wins and is returned to application, or if all the requests fail, the last seen error is returned. You may spot a problem here. I will talk about it in the next slide. systemd offers several services implementing this API for different purposes. The first 2 are the most useful. To simplify clients development, there is the multiplexer service, which multiplexes the queries to all services. And this service is provided by the systemd user dbt daemon. The name service suite offers compatibility with NSS and synthesizes JSON record from the NSS database entries, and is also provided by systemd user dbt daemon. The home service is useful when systemd homed daemon is used, because this daemon creates internally a user and a group record for every home directory it manages, So this service makes these records available to the system. And finally, the dynamic user provides the records for the user defined in systemd service unit files. And the machine service provides records synthesized from containers running on the system registered with systemd that use username spacing. This API is two-way compatible with NSS. We have already talked about the org.systemd name service switch service, which make NSS entries available over the lookup API. But for the other way around, there is NSS systemd, which is an NSS module that makes the JSON records available over regular NSS calls. If you plan to use it, I encourage you to check the systemd user DVD man page for the details about the module. Here I will just remark that NSS systemd will use the multiplexer service if the daemon is running, but the module also works without the daemon running by querying the services itself. Before going on, I would like to remark that unlike in NSS, there is no way to specify the order or the priority. And the API does not define any mechanism to deal with collisions. It completely delegates the responsibility of avoiding conflicting entries to the system administrator. If two different services return a record or a user named Samuel, the first service to answer wins. And also, this API does not provide caching. If it's required, it has to be implemented in the service side. So far, we have seen how the record lookup API is used, how records are transported using varlink. So it's time now to talk about the records themselves. Records have a key value format and are JSON encoded. The number of fields they can contain is huge, overcoming the limitation of the NSS pass WBD and group structs. They can have up to 7 different sections for different purposes. The regular section is the top one and contains general fields that are portable and not security sensitive. This contains, for example, the username. The privileged sub-object of the record contains security sensitive data that only the user the record belongs to or privileged user should be able to see, for example, password hashes. The per machine section is an array and contains resource management related fields for different machines. Each object in the array has a field to match the machine by its ID or the hostname to apply the limits. The binding section is a sub-object caged by the machine ID and binds the record to a specific system. It includes non-portable fields like paths or UID assignments that are valid only on a particular machine, but not necessarily in others. This section is usually populated by systemd homemd, and it's considered part of the record only if the machine ID matches. A good use case for it would be when ID map TDB is in use, for example, because in this case, the UID is local to the system and the same user seed can be mapped to a different UID on a different system. The status section is also a sub-object created by the machine ID and is augmented during runtime and never persisted. The idea is to store here information about runtime resource usage, like for example, how much disk space a user has consumed. The signature contains one or more cryptographic signatures of a reduced version of the record, including only the regular, privileged, and per machine sections, and is validated by some systemd daemons. One of them is homemd, for example. And finally, the secret sections contains user credentials, such as the password or the PIN. Data here is never persisted and never returned when the records are queried. This section is only included for very specific operations, like when systemd homemd creates a new encrypted home directory. The records are intended to be extensible, and the systemd documentation gives some ideas, just to mention a couple: Windows credential information or parental control. To end with the user records, it's clear that they can carry a lot of information, but are there any consumers of all this data out there? Yes, but mostly systemd itself. For example, pan systemd applies various settings to the activated settings, including environment variables, nice levels, and more. Or systemd login, which applies resource management settings to the user login into the machine. The group records are to the NSS struct group, but the user records are to NSS struct stability. They can have the same 7 sections with very similar properties and fields. So let's continue to the methods. There are only 3 of Oops. Hello, I hope you can see me because my client has disconnected. Can you please confirm that?
Yeah, we can see the slides. Yeah.
Okay, thank you.
Yes, again, it was gone for a bit, but now it's back. Good.
Okay. So I will continue. Thank you. I was okay. So we were going to talk about methods. There are only 3 of them. The first one is get user record. The get user record is used to look up for a user. It has 2 optional parameters, UID and name, and depending if only one of them is given or the other, both or none, it can be used by search an user by UID, by name, by both, or enumerate the full user database. Enumeration is optional, and services will return enumeration not supported if they don't implement enumeration. Also, note that the service parameter is mandatory and should be set to the service name being talked to. And this is useful to allow having multiple services listening on the same socket. So one can specify to which one the request is for. In the answers, the incomplete flag is set when sections of the record are removed. This may happen, for example, when a non-privileged user asks for other user record. In this case, the privileged section must be removed and the incomplete flag set. The get group works exactly the same, but for groups. So let's jump to the get memberships method. This method, depending on the parameter given, you can give it a username or a group name, both or none. If just a parameter is you give the username, it will tell you the user memberships. If you give it the group name, it will tell you the group members. If you tell both, it will check the membership. And if you give none, it will enumerate all the possible combinations of all possible combination of memberships in the system. What is most important about it is that it is the only authoritative source for memberships. And what this means, if you remember when we talked about how the API was used, the first service to answer wins. And that service will or may have a limited view of the user memberships. This call behaves different, and the client has to wait for all responses from the different services and combine them to have a complete membership list. All of this is internally done by NSS systemd, or in case the API is directly used, we have the multiplexer service to make our life easier. Steve is asking in the chat, what about other ways to look up users, like for example by UUID or the SID protocol? For that, I guess it will be necessary to extend the API, because the get user record can only take a UID or a username. I guess we could add another call in the API to get users by UUID or SID. Okay, all of this was about replacing NSS systemd. So what are the replaced parts in the end? We can see highlighted in the right picture. The Winbind NSS module is replaced by systemd NSS module, which gets the JSON records from Winbind's varlink service, converts them to NSS entries, and return them to the caller. And do you remember that I had the ferret explaining the motivation for this work? Well, we have now all the pieces of the puzzle to explain it. SUSE started some time ago a project called ALP, Adaptive Linux Platform. One of the goals was to provide an immutable OS to run containers on. The application usually running as daemons in traditional server were called workloads, and the administrator could choose the workloads to deploy in ALP. Imagine now that we want to provide the Winbind workload, but having the users available only inside the container where Winbind is running is not very useful. We also want the Active Directory users and groups to be available on the host, or even better, we may want the AD users to be available in other containers running different applications. To give a real possible example, imagine that we have Winbind running in a container and a Squid proxy running in another container, enforcing access control based on AD group memberships. There are some problems here. To make such setup work, we would need to install NSS Winbind in the host and in every container using the ID users, modify their NSS switch.conf to insert the Winbind module, and then bind mount the Winbind socket directory. But there is another possibility, because all and some base container images already have NSS systemd installed and enabled by default in nsswitch.conf. So we could implement the systemd record lookup API in Winbind and bin mount Winbind container run systemd userdb to the host and other containers. This way, NSS systemd module in the host or in other containers could see Winbind users without having to modify the host or the container images to install Samba parts. About the implementation is finished and fully functional, including enumeration. If you want to give it a try, you have to build Samba with with systemd userdb and activate the service with Winbind varlink service equal yes. Internally, it uses libwbclient, a project on GitHub from Red Hat, where I found some problems. Not sure the status of the project, because pull requests had been waiting there for more than a year for review, and to avoid depending on them, I bundled the library into a third party with the required fixes. And while developing this, I also faced an issue in systemd, where it was having problems handling the domain \name user format, and that fixed it and released it now. Finally, there is an open draft merge request in GitLab, so I invite you to comment on it. And with that, I'm going to show you a demo. I'm going to boot up a Docker Compose environment that has a container running a Samba ADDC, a second container running just Winbind, a third container just with smbd, and a container number 4 running just SSH to illustrate, for example, a separate application having access to AD users. Okay, so let's wait for the environment to start. Okay, now I'm going to open a shell in the container running Winbind. And here we can see that Winbind has created the socket and is listening there. We can use the varlink tool to get the information about the service. And you can see that it's implementing the user database service. We can query the information about the implemented interfaces. We are using here the org varlink service special service for both interfaces. And here we are using varlink tool to make a raw call, a raw varlink call to the service. We are calling the get user record by UID. This is the first one. We are getting the answer. And down, we can see a call to get group record by the group number. And finally, we can see how NSS smbd is used. Here we are calling getEnd for a user, and with this environment variable, we can see all the messages that are sent to the service. Here we can see the call, and the answer is here. We can also, if we, for example, try to enumerate the user, there are much more calls, okay? And also, we can get the full membership, the full group memberships. Okay, and now if we change to the container running smbd, oops. Here we only have smbd running. We see that in NSS switch, well, this is tumbleweed and it's usual. Here we can see that the pass WBD is we are using just the systemd NSS systemd module, and we can authenticate. This is using NTLM authentication because the Winbind socket directory is bind mounted into this container, but in this example, in the SSH case, there is no. We are going to use Cabrero's authentication to SSH into the system. So I can get a ticket and then SSH with the ticket. into the system. With this, I meant to explain that you don't need to, if you are doing Cabrero authentication, it's enough with by mounting the ROM system, the user DB directory. It's not necessary to mount the winbind socket directory. Okay, so I turn to the presentation. It's time now for questions. This is all from my side. Thank you for listening. I will be happy now to answer any question and listen your maybe your opinion about this. Thank you very much.
Thank you, Samuel, so far. So are there any questions? I saw some questions in the chat. Are they answered already, or yeah?
So basically, this is a way to get rid of NSS Winbind.
Yeah, you can extract data from Winbind without NSS Winbind. It's an alternative just for operating systems where systemd is available, of course. And it does not get too deep into Winbind because it's just an overlay, because it hooks in the same place where receiving the NSS Winbind calls. So it uses Winbind in the internals or Winbind are not modified. It's just another way to get the data from it.
I mean, I've always dreamed of just removing the NS switch module from Samba for systems where it's possible. And like years ago, I asked for a specification of the corresponding SSSD protocol, but this never materialized. But now we have a chance, I guess. Looks great. I mean, you have this still in draft. You might become a bit more pushy and just undraft it, so that people start looking at it.
Yeah, maybe I was hoping to get some comments about it, because I mean, but by the time that I wrote it, it was relying on. I mean, the systemd feature was also experimental, so now it's no longer experimental, and I guess we can push for it.
Yeah, just undraft it.
Can we expose seeds through it?
Yeah, the user record is extensible, so yes, we could. Indeed, I was thinking about it after watching your talk. I mean, I found a clear use case for it, or maybe you also discussed about creating a service or something where you could provide, this is my username, my domain, my seed, or whatever information necessary. Give me a POSIX ID number, please. So maybe varlink could be used for that. We could define an interface to get POSIX IDs by information set to define.
I was thinking that, for example, we could have Cabrero's KDB driver that uses varlink to fetch information that can be then used to populate logon info in the path. So effectively, just do a varlink query, and if varlink answers yes, there's a seed, there are seeds of the groups you're a member of, and so on, you just populate this, because the spec for user record already has something like CIFS home server directory and so on. So we kind of already have maybe 2/3 of the information you need for logon info. And that would be independent of the actual implementation of the LSA or SAM on the system, and it would work with the local or with the domain member, and basically this KDC would be picking up these details automatically whenever they come from. The only kind of concern, and it's more for varlink implementation, is that they only have one attribute type, this privileged, which is filtered out, and not like many of those. I would imagine you would definitely want to have different types of privileged applications, access to one information but not to the other. Yeah, this is really exciting stuff. Leonard was asking us, I mean, we sat down with him like 5 years ago when he asked to add varlink to SSSD, provide this, but he never been convincing in the use cases. And this presentation gives much better overview of how really you could use this in real life. So thank you for that. That's really awesome.
Thank you for your work.
Any further comments or questions?
Just one, maybe. What did you use to create these beautiful slides?
It's called present term, and it's a Rust tool.
Okay, cool. Thanks. Really looks very, very new. Very, very cool.
Yeah, much faster to do presentations. Yeah, I mean the syntax is just markdown.